Hey U10s, how are we going? Just want to talk to you about 6G. So basically this is going to be a tutorial through all the set questions for this unit. And it's probably one of the key concepts of the unit as well. So essentially it would be good if you have your own math book with you and you're working through step by step, pausing the video when you need to, and just writing down your own workings in your math book as well. So just the beginning, just a few core concepts from this, and just use the bottom tabs to go to different sections. If you want to skip this section, that's absolutely fine. So y equals mx plus c in special lines. Most straight line graphs can be described by the linear equation, which is in the form y equals mx plus c. So this form here is called the linear equation, and you would be used to this from your stats assignment. Now, in this form, the gradient, which is also called slope, okay? So the gradient is referred to as m. So essentially the coefficient of x, this thing here, is going to be the slope or the gradient, okay? And then the c is the y-intercept, all right? So essentially what do those things mean? This is really important. So if you look at this graph here, the y-intercept is the point at which the line, so the linear equation, the line cuts through the y-axis. So this is your y-axis. So if we look at this line, at what point does it cut through this line here, this y-axis? It's at here. So that is going to be 1. You can kind of see where that's kind of slicing through there. So that's going to be your C. So if I had this line of a graph and I wanted to discern what would be the equation, the first thing I'd look for is the y-intercept. So that's cutting through at 1. So that's why for this linear equation here, for this graph, the y-intercept is going to be 1, okay? Now the gradient is 3 over 2, okay? And that's because in the equation, that's the coefficient of this x here. Now, how do you know it's 3 over 2? That's where, when you're looking at this line, it's essentially how steep it is, okay? Now, if you've got a grid and you've got a line, if it's going up like this, so going up from left to right. So you kind of imagine if you had a person and that person was walking in this direction. If it's uphill, that means the slope or the gradient is going to be positive. If you've got someone that would be, or if you had a line like this and you imagine your person and they're walking this way from left to right, they'd be walking downhill. So that means the slope is negative, okay? So positive versus negative slope is something to consider. So when I'm looking at this gradient here, it's positive. That's a positive gradient, okay? And that's why there's no negative numbers for this one here. Now, how do you know it's 3 over 2? That's because you can pick any 2 points on this line and you can do the slope formula or use rise over run, which is a bit easier, I think, okay? So if I pick any 2 points on this line, now I'll go this point here and this point here. Now, why am I picking these 2 points? The reason is I want kind of parts on this line where if you can kind of see this line, it's right on the corner of the math kind of grid line, okay? You want to pick those points because then it's easier to count the units, okay? Because for this graph, you can see the set of axes here. Every grid line on the math book is 1 unit. Can you see how the 1, the 2, the 3, and then going up the 1, the 2, the 3, they're always on those blue math book grid lines. That's why if I'm picking any 2 points, I want them to be on the corner, okay? Now for slope, it's rise over run, which is essentially how far from those 2 points, how far would you go up? And then how far would you go across? So this is called the rise and this is called the run. Think of rising, going up, and then running, going across. So from this point to this point, how high do you go up? What's the rise? It's 3. How far do you go across? 1, 2, the run is 2, okay? So therefore, the slope is going to be 3 on 2. So that's why in this equation here, it's 3 over 2. So anyway, what's the point of doing this? So mathematicians use rules and graphs to help determine how many items should be manufactured to make the maximum profit. For example, profit would be reduced by making too many of a certain style of mobile phone that will soon be outdated. A knowledge of graphs is important in business. So essentially, we can create rules to predict like financial models for best practice in business, okay? Because if a business makes too much, if we stick with the phone example, If they make too many phones and can't sell them all, they're wasting money. If they make too few phones and they can't meet the demand, they're also missing out on profits. So that's why being able to create mathematical models using data is really important. And this is kind of like the fundamentals of this, the basics of this. Okay, so the key ideas for this topic. Y equals mx plus c is called the gradient intercept form or the slope intercept form. So if you ever see, that's supposed to say slope, if you ever see in a book or question, use the slope intercept form or the gradient intercept form, it's referring to y equals mx plus c. Now, m and c are constants, and in your graphics calculator, they're often used as a and b instead of m and c, but it doesn't really matter. This is still the same thing. So examples of this, y equals 3x plus 4, where this 3 is the slope and 4 is the y-intercept. Y equals half x take negative 3, take 3. So half would be the slope and negative 3 would be the y-intercept. And y equals 2. So that's a trickier one. I'll show you how to do that a bit later. So the gradient or the slope is m, which is the coefficient of x. The y-intercept is the y value at the point where the line cuts the y-axis. And in y equals mx plus c, the y-intercept is c. Okay. So basically, as soon as the line cuts through the y-axis, which is this one here, that's going to be your c. There's a few special lines which don't use the normal rules. So a horizontal line is where y equals c and the slope is equal to 0. Okay. So this one here could be something like y equals 2. So a horizontal line is if you had something like that, and then you'd have a horizontal line going across where the y-intercept is 2. Okay, so that would be a horizontal line, which looks different like this one here. A vertical line is x equals k where m is undefined. So that is said a bit weird, but essentially if you have a vertical line, so something going like that, then we say the slope is undefined. And this will pop up not very often, but it does pop up, undefined. So it's saying like you can't figure out the slope, okay? And that's because as it gets steeper, the slope increases. The point just before vertical, the slope would be getting closer and closer to infinity. Like it's basically such a ridiculous number, you can't get to it. And then when it gets to that exact 90 degrees, we say it's undefined. It doesn't have an answer. And we'll leave that last one. Okay, so now let's go through some of these problems. For each of the following equations, state the gradient and the y-intercept. Okay, so remember, gradient is slope. And I kind of prefer to use the word slope. So let's go slope and let's go y-intercept. And we'll just make a little table. Actually, I should probably use, can I use straight lines here? Okay, so all we need to do here is make sure that they are in the slope-intercept form, which is y equals mx plus c, plus c. And when they're in that form, that's supposed to be an x, and when they're in that form, we just need to look at the coefficient, which is m, and that's going to be the slope, and the y-intercept is going to be the c. Okay, so once we're kind of in that form, we're good to go. So for the first one, is it in the form y equals mx plus c? Yes, it is. So the slope is going to be 2 and the y-intercept is going to be 4. 2, 4. For B, is it in the form y equals mx plus c? Yes, it is. The slope is 6 and the y-intercept is -7. So just be careful to include that sign. This one, is it in the form y equals mx plus c? Yes, it is. The slope is going to be -2/3 or -2 on 3. Now, when it's a negative number, you can see the negative sign is kind of before the 2. It's pretty much, the negative number is assigned to the numerator, the top number. So whether you write it as -2 on 3 like that, or -2/3, it's pretty much the same thing, but this first one is probably a bit more accurate, but they're both fine. And then the y-intercept is going to be 7. For D, is it in the form y equals mx plus c? Yes, it is. the slope is going to be -7, and the y-intercept is going to be -3. For E, it's in the right form. So we've got 3/5, so 3/5, and the y-intercept is going to be -8. And F, it's in the right form. It's going to be 9 is the slope, and the y-intercept is going to be -5. And that's it. So question 3, sketch the graph of the following by considering the y-intercept and the gradient. Okay, so I'll get my grid line up here. Now, with these questions, you can do multiple questions on the same set of axes. So don't draw a new set of axes for each question, just do multiple lines on the same one. So for A, I'll do some working out over here. Sorry, for A, I just want to get the slope and the y-intercept, okay? Because those are the important two things that I need to draw my line. So I've got the slope is 2 and the y-intercept is 3, just like we did in the previous question. Slope is 2 and the y-intercept is 3. Now we're going to do one more trick here. Instead of just having the slope as 2, I'm going to make it 2/1. So we're always going to turn it into a fraction, okay? And I'll show you why in a second. So the first thing we'll do when we graph these is we want to get our first point as the y-intercept. So I'm going to get my y-intercept of 3, and I'm going to look at my graph, and I'm going to count up 1, 2, 3, and I'm going to put my y-intercept dot right there. So it's always going to be on the y-axis, okay, at the third point up here. And then what I'm going to do is I'm going to draw my second point. Now my second point is from this point here, I'm going to do my rise over run, and that's where I'm going to use my slope. So my slope is going to be my rise. The numerator of the slope is going to be my rise, and the denominator is going to be the run, okay? So essentially what I'm doing is I'm going 2 up and 1 across, 2 up and 1 across. So I'm counting up 1, 2 up and 1 across. And that's going to be my second point there, okay? That is my 2 dots, and you can draw a graph, you can draw a line with 2 data points. I'm just finding my line here. There we go. And then I can essentially get my line and kind of, now this is going to be a bit tricky because I have to, now when you draw a line through 2 points, you kind of want to draw it through, you want to be accurate first of all, and you can see I'm kind of accurate, kind of not accurate here. And you want to go beyond the 2 points. So you don't have to go too far beyond, but you just have to go a little bit beyond those 2 points, okay? And then what you would usually do is you would usually write the equation of the line next to it, okay? So I would be going y equals 2x plus 3, okay? And when you have multiple lines going on, it can get a bit complicated, but that's okay. So the second one is y equals 3x take 12. So the slope, oops, what have I done? The slope is 3. So remember, I'm just looking at the coefficient. So that's 3. And I'm going to turn it into 3 on 1. Same trick as before. And the y-intercept is -12, okay? Now this is a tricky one because my graph doesn't even go to -12. So if I was drawing this on paper, I'd have to do a bit of a reshuffle, okay? Oops. Because what I'm doing essentially is I'm going from 10 and then 11 and then 12. So I'm going to be a bit cheeky and just kind of say -12 is down here because -10 is on here. So -11 and -12 would be here. So you just imagine that line went a little bit further, and that's my -12. My slope is 3/1, so that's the rise of 3 and the run of 1. So from my 12, I'm going to be doing a rise of 3, so 1, 2, 3 on that 9, and then a run of 1. So that's my second point there. And you can kind of do it again if you want to. A rise of 1, 2, 3. Now I'm just thinking if I did this right. 1, 2, 3. I think I just did it. I think I did that dot a bit wrong. So that would be 1, 2. So -10 is there. Sorry, 3. So it would be here and a run of 1. I'll just do it again just to kind of show what's going on. So 1, 2, 3 is the rise and run is 1. So that would be there. And you could kind of keep going 1, 2, 3 up, 1 across. And that's how the line would look. So then we'll grab our line, and we'll go just through those points like that as best as I can. Now that's not super accurate, unfortunately. You can kind of see that it's missing one of my points there. That's probably a bit better. Okay. And then we'll draw that. So that's going to be, I'll do a different color maybe. So that's going to be y equals 3x take 12. Okay. So the next one, we'll go y equals x plus 4. So for C, the slope is going to be, now there's no coefficient there, so that means it's 1, okay? And we'll do 1 over 1 for the same trick as we've always done. And the y-intercept is going to be positive 4, okay? So we'll get our y-intercept first, so positive 4. So we'll go 1, 2, 3, 4. So that's here. I might just get my orange. Yep. And then the slope is 1 and 1. So that's a rise of 1 and a run of 1. So that's here. Rise of 1, run of 1 here. You don't have to do it more than once. And then that will be our line. So we'll just grab our shape here. Something like this. Yep. So that one there is going to be, oops. So that one there is going to be, oops, wrong color. Y equals x plus 4. Okay. Now I'll just show you very quickly on the graphics calculator. If I just go back to the beginning here, you can graph these on your graphics calculator. So we'll go graph. I might just move my face here. We'll go graph. And then you can put in your functions here. I'll just delete these ones that I've already done. So I might just graph these ones here. So I'll graph A, C, and E. So the first one is 2x plus 3. So the y is already in there. So y equals 2, the x button's here, x plus 3. So that's the first one. The second one is 3x take 12. 3x take 12. The third one is x plus 4. So x plus 4. And we can graph all of these, okay? So we just press draw, and we've got all of them there. Now, you can't really see them all properly. So what I'm going to do is I'm going to go Shift, and there's a View Window button, VWin. So I'll click VWin, okay? Now, if you have a look over here again, how much can I actually see from this grid line? What's the maximum and the minimum? So basically for the y-axis, the maximum is 10 and the minimum is -10. And for the x-axis, the minimum's 10, the maximum's 10. So that's pretty much what I want to do here. So my x-min, I might do -10. And my x-max, I might do 10. This is just my scale. Now the y-min, I might go -12 because remember this one went down to -12. And I'll do my max of 10, okay? And then I can just press exit and then I can press draw again, F6. And then it kind of zooms out a little bit and you should be able to see these intercepts. Now, what I'm looking for is essentially, are the slopes of this similar to what I've got here? Now, it might look slightly different because of the perspectives, but it looks pretty good, okay? And what you can actually do if you go Shift, you can go Sketch. Oh, whoops, not Sketch. You can go Trace, and there's a little crosshair there, and you can kind of just go along and you can see all the different sections of your graph. Another thing you can do is you can go G-solve, and you can find the y-intercept, this button here. So the y-intercept for, so it's saying which graph you want, so it's the blue one, and the y-intercept is 3, which is what we already calculated. So if I'd go that again, if I go Shift, G-solve, y-intercept, which one? I'll move up to this one. See how it's kind of blinking? I just moved up to that green one there. Execute, y equals 4, which is the same as what we've got. So the calculator can kind of show you the y-intercept. All right, we'll stop it there. I'm going to work through the rest of the questions as well, but we'll leave that for a second video.